Good evening. So I got a question via email about the distributive property uh, and about why addition does not distribute over multiplication. Okay. Excuse me. So um, let's just think about the distributive property for just a second. Let's just pretend I have something like 2 times, and why is it doing that? 2 times 1 plus 3. Okay. Now, keep in mind that there's an understood multiplication here. Anytime that you have the number in front of parentheses, it's understood to have a multiplication symbol. So when you distribute something, you have two different operations. When I say operations, I'm talking about like multiplication, addition, subtraction, division type stuff. And you've got one outside the parentheses and one inside the parentheses. And when you distribute, you take whatever that number is and that operation next to it, and you apply that to both of the things inside the parentheses. So if we have this is distributing multiplication over addition because the multiplication's on the outside. So that would be 2 times 1 plus 2 times 3. Right? Or 2 plus 6 would be 8. Okay? And that works out because even if you follow your order of operations and you do the parentheses first, 1 plus 3 would be 4. And of course, 2 times 4 is going to equal 8. Okay? Now, that works out because multiplication is just repeated addition, right? Okay? So a third way maybe to look at this distributing multiplication over addition is that 2 times 1 plus 3 really means 1 plus 3 plus 1 plus 3, right? Because I'm repeatedly adding that 1 plus 3. That's what the 2 times that thing means, right? And we know that now I have everything written as addition. And addition is commutative and associative, so you can rearrange addition any way you want, basically. Right? So I could write that as 1 plus 1 plus 3 plus 3. Or 2 times the 1 plus 2 times the 1, right? Because there's 2 1s here, right? That's multiplication, repeated addition type stuff. Okay? And there's 2 3s. So I could write that this way. And that's what the distributive property really is kind of doing. Okay? But that doesn't work if we rearrange the multiplication and addition. Okay? So if we had something like 2 plus 1 times 3, and we just switch where those are at. If I try to distribute, I have to take that 2 plus and kind of attach it to each of these pieces that are in here. So that would be 2 plus 1 times 2 plus 3. But that would be then 3 times 5, which would be 15. But if you follow your order of operations and do what's in the parentheses first, that's 2 plus 3, because 1 times 3, which would just be 5. And you see that there's a big difference. And the problem becomes when you are rearranging things, thinking about the definitions, that 1 times 3, let me, you know what, let me change this example a little bit, because that's going to be really too totally boring. So let me think of it so you can see more stuff right now. Let's pretend for a second got 4 times 3. Okay. Now, if I think about what the multiplication means, 4 times 3 just means we're adding 3 4 times, right? Plus 3 plus 3 plus 3. Now, I've got everything written as addition and stuff, but unlike in the last case, no matter how I regroup this, it's not going to wind up being the same, right? Because we're just adding a bunch of 3s in a 2 here, Whereas if you tried to regroup stuff and use that distributive property, that would be 2 plus 3, 6 times 5. This would wind up being, 5 plus 5 plus 5 plus 5 plus 5. And we need one more copy in there because there's 6 of them. And you can see that's kind of wildly different than if we just have the 2 plus all of those 3's. You just can't take addition and distribute it over multiplication because it doesn't work out the same. When you get down to the bare bones kind of definitions of what multiplication means, and then once you rewrite things in terms of additions on how you regroup stuff. So you've got to be real careful about the distributive property. You can distribute the multiplication over addition. You can distribute multiplication over subtraction. But you can't switch those because the number of 3's or 5's or whatever it is doesn't match up anymore if you try to switch them backwards. So be real careful. As far as basic order of operations stuff, if it's all numbers, the distributive property really isn't all that handy. Okay, you can tell real quickly up here, it's a lot more efficient to add the 1 and the 3 and just follow your order of operations. Okay, the handiness of the distributive property comes in when you're dealing with variables. Okay, and you're trying to solve equations or simplify things that have variables involved. So if I have 2 times x plus 3, I don't know what x is, so I can't just add it to 3, right? So I can't really follow the order of operations and add those first, but I can use that distributive property to take 2 times x and then 2 times the 3 and write that as 2x plus 6. Now, simplifying an expression like this is kind of handy when we start solving equations or doing things along those lines. So it's a useful tool to have, but it's really not useful when it comes to just arithmetic, when you have all numbers that you're dealing with. In those cases, just follow your order of operations. But once we throw in the variables, it may be a useful thing to do. I hope this answers your question. If not, just let me know, and I will try to nail down a little further what you're asking about.